you read about in your Okay. So Cramer's rule uses determinants to write the solution to a system of linear equations. And we know how to find determinants. Alright? We're probably going to work with just 2 by 2s and 3 by 3s. So a system with 2 unknowns, a system with 3 unknowns. Okay? We cannot use this rule if the determinant is zero. Alright, so we're a little bit limited. Okay. We have to use different methods. No, there's no other method that solves this. Right. Okay. What? This is number 6 for our options of solving systems. Okay. So here's how we do it. All right. For each variable, we're going to take what's called the determinant of x over the determinant of the system. All right. Now, D, the determinant, is just the determinant of the coefficient matrix. Okay, so that's going to be your denominator for each variable. So once you find that, that's going to be your denominator each time. Okay, now this D sub x, all right, what that means is, okay, we're going to take the determinant of the coefficient matrix where the x column is replaced by the constant.
Yeah.
Okay, if we want D sub y, we're going to take the y column and replace it with the constants of our system. Now when I say constants, which numbers am I talking about? Okay.
If I have like 6x plus 3y and 6 and 3 constants.
That would be those would be our coefficients.
Oh.
If you have 6x plus 3y equals 2, 2 is your constant. Okay?
Yep.
Right. Whatever on the right side of the equal sign, that's the column that you'll replace for your d sub x, d sub y, d sub z. Okay, well if you're finding x, then you're going to take the x column and replace it. If you're finding y, you'll take the y column. Okay. Are we ready to see it? Are we good? All right. Please write down this system. Please write down this system. All right, let's first talk about D. D is just what? A determinant of... Okay. So, my first row is what? I see that. Second row. Third row. Okay, so now doesn't equal 1.
No, because it ends
No. Here's our 3 by 3 matrix. This is our denominator for each of our variables. So we need to find this determinant. How do we find it? Okay. We're going to practice this one without our calculator. Go for it. Your thumbs up if you have it.
Oh, I got it.
I thought I said no calculator.
Nah, you got you on so much examining. So,
Okay, I will help you later. Carl, what's our determinant? Do you agree with it? Okay, let's check our values. You should have 0 plus 6 plus 24.
plus, dang it.
Oh yeah.
Oh, you guys.
Okay, minus 0, 4, 16. Okay, 30 minus 20. All right, so to find x, all right, we are going to take the determinant of the coefficient matrix, but we're going to replace the x column because we're solving for x. So instead of the -1, 2, 3, I'm going to put 1, 0, 2. Where did I get those numbers from?
Ah, yeah.
Okay. And everything else stays the same.
That's weird.
That's the numerator, and we're going to divide by that. All right. This is the coefficients matrix, except since we're solving for x, I replaced our x column with these numbers. Okay? So then when we go to solve for y,
You replace it?
we are going to have the coefficient matrix, except our y column is going to be replaced with 2, 0, -4. Oh, whoa, where did 2, 0, -4 come from?
Over there. He just read.
I did rewrite the whole thing. I'm sorry. 1, 0, 2. Thank you, Dave. Okay. Same matrix is up there, except the y column is now replaced with the 1, 0, 2.
Oh, crap.
All right. And then for z, we're going to have our coefficient matrix. What's the y column? But now our z column is 1, 0, 2. All right, so we're going to split up the workload here. Pods 1 and 2, please find me the numerator for our x. Pods 3 and 4, you have y. Pods 5 and 6, you have z. By hand. Good practice.
X.
It's a determinant.
No.
So same thing as up here. Copy. Well, for right now, just find that. find the numerator. I'm just worried about the determinant for each numerator. Just find me the determinant. Alright, parts 1 and 2. What is the determinant of d sub x?
4 over
What's the determinant? 8.
8.
So we have 8 over 10, which reduces to 4/5. Parts 3 and 4. What's the determinant for d sub y? Negative 15. Do we all agree? So we have negative 3/2. Then 5 and 6, d sub z is
16.
so we have
Negative 8.
so 4/5, negative 3/2, negative 8/5. Now, if you were solving this by algebraically by elimination, would this get a little ugly? Because we have fractions. Yeah. Okay, now finding determinants, okay, you may feel like it's a little tedious because you're doing the same, you're finding 4 determinants. However, if they're fractions, you don't have to think very hard. Okay? I like Cramer's rule. I think it's nifty. Okay? Now can you imagine 2x2s? Yeah. The 2x2 systems are going to be really nice with Cramer's rule. Okay? Alright, let's talk about the area of a triangle. Okay, you read about this. Go ahead and write down the formula. So you have it to reference. Oh, why is it plus or minus?
No, I was just saying in general. Well, because like if the determinant's negative, then you gotta have positive area, so.
Very good, Chase. Thank you. We are finding the area of a triangle, which means we're going to have a positive value for area. Okay? So if your determinant is negative, you are going to choose the negative 1/2. If your determinant is positive, you're going to choose the positive 1/2. You will never choose both plus or minus. Okay, you'll choose one or the other so that your area ends up being positive. Okay, so basically what you have your plus or minus 1/2. You have a 3x3 matrix with these slashes, meaning you're finding the determinant. All right, you're going to put in your coordinates, and it really doesn't matter which one comes first in your rows. You just need to put in your coordinates xy, 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 and then your third column is 1. Now I know some of you are questioning, okay, who sat down and thought of this? Why does this work?
I did.
I know that was a question on some of your. Okay, here is how they came up with it. All right. Think so? Okay. Thank you. All right. So here's what this person did. We have a triangle with coordinates A, B, C, D, and E, F. What they did is they went ahead and they made a trapezoid with it. Okay? And they did all this fancy math. All right? I won't bore you with it. If you want to look more into this, you can. But what happens is they end up getting this right here when they find the area of the trapezoid. Well, this is what happens when you take the okay of that AB1, CD1, EF1. Okay, so there is a reason to this madness. All right, if you want to look more into this, you can. I can give you the link. All right. Let's do this. Let's find this area. Okay. Okay, well, we have plus or minus 1/2. We're going to have a 3 by 3 determinant where we're just going to plug in our coordinates in the rows, x, y, x, y, x, y, and then our third column is 1, which actually makes it nice because 1 is a nice number to multiply by. And look, we have a 0. That's going to be nice too, right? That's the point. It's 1, 1, 1. Okay, so we don't know if we need the plus or minus with the 1/2, so we'll leave it as plus or minus. All right, let's do our criss minus cross. We have 2 plus what?
4,
0 plus.
6.
Okay, I see where you're from that. Minus 8 plus 0. All right, so this gives us 8 minus 11, which is what? -3. Do we want to choose the plus or the minus 1/2?
The minus.
No. Your enthusiasm is appreciated. All right, so we have 3/2 unit squared. That's it. Okay. Well, yeah. Let's think about this triangle. 1, 0, 2, 2, 4, 3. Not very big, right? Okay. Now, what would happen? Okay. We chose the minus, so we have a positive area. We can't have a negative area. All right. Now we talked about this a little bit before when we were talking about our reading assignment. What would happen if the area of my triangle came out to be 0? Our points would be collinear. So, if the determinant of x, y, x, y, x, y with a column of ones, if that determinant ends up being 0, then we know we have points that are collinear. Does it have 2 L's? I didn't know the word, but there's 2 L's. Alright, so let's test these points out. -2, -2, 1, 1, and 7, 5. If I say, hey, are these collinear? You're going to put these in xy 1, xy 1, xy 1, and we're going to find the determinant.
I guess it's easy.
Do it in your calculator.
Well, that's why she's doing
Alright, what is it? What's our determinant? -6. Are these points collinear?
No.
Alright. Oh, dang it, this was my example. Okay. Okay, now, what would happen if I wanted to find the equation of a line between 2 points? Okay, let's go back to this right here. If I have 3 points that are collinear, I put xy1, 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 and that determinant is going to be 0, right? Okay, so if I want 2 points to be on the same line, okay, I can put those 2 points into this formula, and then I need a third, right? So our third point, we're just going to name xy. That way, when we find the determinant, it's actually going to help us find the equation of the line. Okay? So if I give you 2 points and I say, hey, write the equation of this line using a determinant, okay, we're going to use the fact that 3 points are collinear, means this particular matrix has a determinant of 0. Okay, but our third point, we're just going to name it XY instead of actual numeric values. Right. Okay. Ready?
Yeah.
I want the equation of the line passing through these 2 points. Now we know how to do this algebraically. Let's do it using the determinant of the matrix. Okay. All right, so what we're going to do is our first point's going to be xy, and then we're going to put in 2, 4, and negative 1, 3, and then we have our columns of 1. And we want this determinant to equal 0. Can't use a calculator here, Daniel. Gotta do this one by hand. So we will rewrite the first 2 columns. Okay? So let's do this. Let's find the determinant, and our determinant equals 0. So x times 4 times 1 plus y times 1 times negative 1. So negative y plus 1 times 2 times 3. Minus the quantity, negative 1 times 4 times 1. 3 times 1 times x. And 1 times 2 times y. And this equals 0. Alright? So now we can combine like terms. What is 4x minus 3x?
X.
Negative y minus 2y. 6 minus negative 4. So to put this in standard form, ax plus by equals c. Okay, matrices can be very useful, all right, as we've seen here and in, solving systems of equations, all right. Now, if any of you go on to study like higher level mathematics, there's a class called linear algebra, and it's all working with matrices and really cool things you can do with business. Okay. There you go. I love matrices. Okay, so here is your assignment. Our test is on Monday, which means tomorrow we will